The basic question of just how warm the sea surface temperatures can get, let's say, under perturbations of the greenhouse gases by human beings or orbital forcing or whatever. A big debate erupted in 1991 after Ramanathan published a paper based on an El Nino satellite data analysis that the warm pool over the West Pacific, for example, warm sea surface temperatures have this deep convection, tall clouds reaching the upper atmosphere and cooling the sea surface temperature, cooling the temperatures at the cloud tops. As you remember, the deep tropics have a minimum in OLR as you look, or even air temperatures related to reduced OLR because of these cold cloud top temperatures. And the argument there was that there is also a super greenhouse effect created by the humidity loading associated with these warmest sea surface temperatures, and that they increased also the cirrus clouds, which tend to allow the shortwave radiation to come in but are opaque to outgoing longwave radiation. So the argument was that the warmest temperatures could keep getting warmer and warmer. This led to several papers after that, big debate arguing that such a cloud feedback doesn't make sense because the circulation associated with the deep convection is large scale, with convergence happening in the Hadley cell, in the Walker cell, and that would have a dynamic component. And you remember we looked at the tropical temperatures, that the temperature gradient is very weak in the troposphere of the deep of the tropics, which means there is some dynamics that tends to smooth out the anomalies, warming anomalies in the atmosphere and so on. And a counter hypothesis was proposed that actually there is kind of a feedback that is related to cirrus. Dick Linson called it iris expansion, kind of how our eye adjusts to change in light, etc. And Rong Fu had a paper in 1992 arguing a cirrus thermostat as well. And the idea is that associated with these warming and deep convection with rising tropopause and weak OLR of the cold cloud top temperatures, there are these subsidence that we have talked about before in terms of the radiative cooling and diabatic adiabatic compression in the downward branch. And the argument here is that the drier and clearer air actually reduces the cirrus clouds and allows more OLR to get away to space, and hence creates a negative feedback which doesn't allow the warming and the super greenhouse effect and so on to happen. This is a key debate because Noel himself, in I think from MIT in the 1970s, had argued somewhat similarly that the increased cloudiness actually reduces the albedo and incoming shortwave radiation, and that would actually cool the SSTs. And of course, with warmer SSTs you have non-linear exponential increase of evaporation from the sea surface, which would cool the SSTs as well. You know, the Clausius-Clapeyron has a exponential temperature dependence when it comes to humidity in the air with warming temperatures. So that then also is related to later arguments which say that there is something like an ocean dynamic thermostat. So even if you put global warming fluxes everywhere, as we already saw before in terms of the warming trends in the Pacific, we argued that maybe in the data there is less warming in the eastern central Pacific than in the west, which is confirmed by data, but there is always issues with data as well. And then there is a seasonality of the sea surface temperatures itself. So whether the seasonality of the trend matters is also not completely resolved yet. But the idea of the ocean dynamic thermostat, which started with Amy Clement, Richard Seeger, Mark Kane, and so on, argues that as you try to warm the global temperatures, the warming in the east is actually slower than the west, which would give you, as I said before, an increase in the east-west temperature gradient, which means an increase in the east-west pressure gradient, which means a increased easterly wind in the deep tropics at least, which would further increase the upwelling and give you further cooling or reduced warming in the east, and this would amount to essentially enhanced uptake of heat by the ocean. This is why this is called ocean dynamic thermostat. The previous figure I showed that I mentioned, Richard Seeger's paper, basically looks at the sea surface temperature response associated with the warming since the 1980s or so, and argues that in fact east-west temperature gradient has increased, the east has warmed less, and especially he goes on to say that the models are failing to capture this particular response of the change in the east-west gradient associated with global warming, which obviously would have great consequences for the rate of warming, and also the more recent slowdown in the warming since 1998 to about 2012 or so, which was debated greatly as the global warming pause, also is argued to be related to this La Nina-like response where the East Pacific is either cooling or warming less than the West, allowing the positive feedback of the winds and the upwelling and increased ocean heat uptake. Associated with that, there is evidence that the trade winds have gotten stronger in the last several decades. Ocean has taken up more heat, and in fact some of that heat in the Pacific is getting pushed into the Indian Ocean via this Indonesian through flow that goes through the Indonesian seas into the Indian Ocean, and there is evidence that the Indian Ocean is building up heat content over this same period. Okay, so that's kind of the idea of SST regulation. The main story there is that there doesn't seem to be this super greenhouse effect and continued increase in sea surface temperatures. There seem to be these kind of dynamic thermostat effects, which could include the ocean or just the cloud radiative feedbacks, which probably limit how warm the ocean can get. Okay, I will leave it there, and then we will come to more details in the following podcast.